Hello guys, in this video I will be discussing module 1 for thermodynamics 2, or it is all about thermodynamics processes. Actually, this is only a review of your thermo 1, okay? So let's start. Let's review the laws of thermodynamics. So meron tayong tinatawag, 'di ba, na zeroth law of thermodynamics. Ang sabi sa zeroth law of thermodynamics, when two bodies are in thermal equilibrium with a third body, they are in thermal equilibrium with each other and hence are at the same temperature. So for example, pag masasabi natin na thermal equilibrium ang dalawang bagay, kapag magkapare sila ng temperature. So kung yung dalawang bagay na yon is in thermal equilibrium sa pangatlong bagay, ibig sabihin, in thermal equilibrium din sila sa bawat isa. Okay? So, ibig sabihin, nasa iisang temperature. So, for example, itong dalawang to is in thermal equilibrium. For example, nasa 50 degrees Celsius silang dalawa. At sabi is thermal equilibrium din sila sa letter B. Ibig sabihin, 50 degrees Celsius din ito. Okay? So, iisa lang sila ng temperature. Yun ang sabi sa zeroth law of thermodynamics. Meron din tayong conservation of mass. Sabi sa law of conservation of mass, the total mass is a constant. Okay, net mass transfer to or from a system during a process is equal to the net change, increase or decrease in the total mass of the system during the process. As with all laws, this is deduction of experimental evidence. It can be demonstrated but not proved to be true. Okay, so sabi sa conservation of mass, kung ano yung mass niya nung unang state, ganun din yung mass niya after reaction. Okay? Pwedeng magkaiba lang ng form, pero yung mass niya parehas lang. Okay? So, kung ang mass nito is, for example, 5 grams before the reaction, after the reaction, 5 grams pa din siya. Yung ibang mass, pwedeng iba na yung form, iba na siyang form of matter. Pero, in total, 5 grams pa din siya all in all. Okay? The first law of thermodynamics, sabi naman dito sa first law of thermodynamics, or also known as the conservation of energy, based on experimental observations, the first law of thermodynamics states that energy can neither be created nor destroyed. It can only change form. So, parang law of conservation of mass, um, ganun din ang energy. Kung ano yung unang state na energy, yun din yung kalalabasan. Magkaiba lang ng form. Okay? Pwedeng nung unang state niya, potential energy siya. After state niya is kinetic energy. Pero parehas ng amount. Okay? So, energy before the transformation is equivalent to energy after. Okay? So, sabi dito sa first corollary first law of thermodynamics is ito ay energy in is equals to energy out sa closed system, 'di ba? So ano bang closed system? Ang closed system is energy can uh, enter but mass cannot. Okay? Ang energy pwedeng pumasok at lumabas, pero yung mass hindi pwede. So, yun ang closed system. So, itong formula na to, change in energy is equivalent to Q minus W. Okay? So, Q is the heat transfer and W is the work. So, 'di ba sa closed system, dalawa lang naman, work at saka yung heat. Okay? Dalawa lang naman ang pumapasok. Okay? So, next, the second corollary first law of thermodynamics is applied to open system. Ito yung ang mass mo is pwedeng pumasok at lumabas. So, kaya nagkaroon na tayo ng enthalpy, kinetic, potential, saka work. Okay? Hindi na lang siya heat at saka work. Meron ng iba kasi moving ang mass natin. Okay? May kinetic, so may speed. Pwedeng may potential kasi pwedeng magkaroon ng height. Okay? And enthalpy. Okay? So, yun ang application ng first law of thermodynamics. Dalawa siya from to closed system at saka open system. Sabi naman sa second law of thermodynamics, whenever energy is transferred The value of energy cannot be conserved and some must be permanently reduced to a lower value. The second law of thermodynamics states that no heat engine can have an efficiency of 100%. So parang akala ko ba energy in is equals to energy out? Yes, energy in is equals to energy out. However, merong part dun sa energy out na hindi mo na maita-transform pabalik. Ito na yung tinatawag na losses. Hindi na siya um, hindi na siya magagamit for work. Okay, tapon na siya. Pero parehas pa rin yung equivalent, nagkaroon ka lang ng losses. Okay, so parang ito, energy before, ayan. Tapos nagkaroon ng energy out, pero merong unusable energy after at saka usable energy. So parehas pa rin ang amount ng energy. However, yung some portion niya, hindi mo na siya magagamit. Wala siyang work. Okay? Kaya, sabi rin niya is no heat engine can have an efficiency of 100% kasi hindi mo yung ipinasok mong energy or yung energy niya on the first state is hindi yun lahat magiging work. Hindi lahat yun capable to do work. Okay? Kaya walang 100% na heat engine. Laging may losses. Okay? So, sabi sa one of the corollaries of the second law is the Kelvin Planck statement. Sabi niya, it is impossible for any device that operates on a cycle to receive heat from a single reservoir and produce a net amount of work. Yun nga, sabi, hindi pwedeng um, from a single reservoir is yun din yung kung ano yung energy niya na una is yun din yung amount of work. Hindi pwede, kailangan talaga may losses. Okay, may losses talaga. Hindi pwedeng lahat ng energy niya nung una is mako-convert niya into work. May tapon. Okay, kaya yung single reservoir, sabi niya dito, receive from a single heat reservoir. So for example, nasa 100 degrees Celsius siya. Okay, 100 degrees Celsius. Tapos yung buong heat na yun is mapoproduce to work, hindi po possible. Okay? Meron po talagang energy na lalamig lang at matatapon. Okay? So, sabi naman sa second corollary, yung closure statement, it is impossible to construct a device that operates in a cycle and produces no effort other than the transfer of heat from a lower temperature body to a higher temperature body. Dito, sinasabi niya na ang ang heat flow or energy flow is from high to low. Okay? Laging from high to low. Yun ang heat flow natin. From mainit, palamig siya. Hindi pwedeng mangyari na from cold to hot unless may gagawin kang work. Okay? Pero ang normal kung wala kang i-input na work from hot body to cold body. Okay? Kailangan mong magbigay ng effort o ng work kung gusto mong maging cold to hot. Yun ang sinabi sa closure statement. Okay? So, normally, ang heat flow is from hot to cold. Okay? So, yun ang tatandaan. Second law of thermodynamics, closure statement. Meron pa tayong third law of thermodynamics. Sabi dito sa third law of thermodynamics, it provides an absolute reference point for the determination of entropy. Ano ba yung entropy? Ito yung measurement of chaos o yung kaguluhan sa particles, sa molecules. The law states that the entropy of a pure crystalline substance at absolute zero temperature is zero since there is no uncertainty about the state of the molecules at that instant. Sinasabi lang dito guys, pag meron tayong perfect crystalline yung talagang froze siya, ang entropy nun ay zero. Kasi solid eh. Okay? Zero. Zero ang absolute temperature niya. However, hindi pa napuprove kung there is actually a perfect crystalline. Okay? So, parang sinasabi lang dito, gumawa sila ng reference point na absolute zero kasi hindi natin siya kayang abutin. There is no such thing as zero entropy. lahat is merong chaos siya. May measurement of chaos. Okay? So, kapag perfect crystalline substance, yun yung absolute zero. Okay? Perfect crystalline. Okay? Kasi, di ba ano ba ang pinakamataas na entropy? Di ba gases? Bakit po gases? Gases ang pinakamataas na entropy kasi yung molecules ng gases ay magalaw. Di ba? Kasi it follows the volume of a container. So, kung ano yung volume, okay, yun din, ay, kung ano yung volume ng container, yun din yung volume ng gas. So, free siyang yung molecules niya ay free na nakakagalaw. So, it vibrates, it rotates, lahat yan. So, kaya merong entropy. Okay? Mas mataas yung entropy niya kasi mas magalaw siya, mas magulo. Okay? Kapag liquid, medyo lang, medyo. Okay? Tapos, kapag solid, pag solid ang bagay, vibration. May vibration pa rin siya. May entropy pa din. Okay? Pero lesser compared to liquid and to gases. Okay? So, sinasabi dito, pag perfect crystalline, zero entropy. So, parang imposible, 'di ba? Kasi pag inisip natin, kapag solid nga ang bagay, may vibration pa. So, parang ah, nag-formulate lang sila ng absolute zero para may reference point tayo. Okay? So, that's it. So let's proceed to the next thermodynamic processes. The state of a system can change as a result of its interaction with the environment. Okay? Um, The change in a system can be fast or slow and large or small. The manner in which a state of a system can change from an initial state to a final state is called the thermodynamic process. Yung binabangkit ko kanina na reaction, halimbawa, ito yung initial state niya and then na-transform siya dahil sa interaction with the environment. Okay? Magkakaroon siya ng final state and that is called a thermodynamic process. Yung from initial to final, ang tawag doon is thermodynamic process. So, meron tayong dalawang process na tinatawag sa thermodynamics. Yung quasi-static process at saka non-quasi. Yung quasi-static process um, is shown as etong arrow na to. Kasi, the path of the process between A and B can be drawn in a state diagram since all the state the system goes through are known. Kapag alam mo kung ano yung pinagdaanan, okay, ng process na yon, ang tawag doon is quasi-static. Kapag unknown, hindi mo alam, pwedeng ganito siya nangyari or ganito siya nangyari, anything na hindi mo alam, okay, ang tawag doon is non-quasi-static process. Okay, so ang ginawa ng mga scientists is nag-produce sila ng known processes from A to B. Ito yung mga tinatawag nating ito. Meron tayong apat: isobaric process, isochoric process, adiabatic process, and isothermal process. Okay? Sa isobaric process, ang pressure ay constant. Okay? And the other factors are variable. Okay? Ang pressure ay constant. So, pag isochoric naman, ang volume ang constant and the other variables are changing. Sa adiabatic process, no heat transfer. Ito yung isentropic tsaka polytropic adiabatic process sila. Okay? Walang heat transfer. Isothermal process naman is constant temperature. So, kapag kinompute natin yung work netong apat, ang work ng isobaric process is pressure times delta V or the change in volume. Okay, work boundary yan. Okay? So, sa isochoric, volume remains constant. Dahil volume niya ay remains constant, wala siyang work. Sa isothermal naman, dahil constant ang temperature, ang equation niya is PV ln V2 over V1. And then, sa adiabatic process naman is MR change of temperature over 1 minus n. Okay? Ito yung polytropic tsaka isentropic na tinatawag. Okay? So, that's it. I hope you remember or have a review for the thermodynamic processes. Okay? Thank you very much.